Welcome back. In this video, we're going to solve rate times time equals distance problems. So we've done some rate times time equals distance earlier this year, and we're going to revisit those again. So we know that rate times time equals distance, but solving for time, we know time is equal to distance divided by rate. You'll also need to recall our wind and current problems. With the wind or current at your back, the current would speed you up, wouldn't it? The wind at your back helps you go faster. So our capital R, our overall rate, was made up of R plus C. Now, when the wind, and that's little r plus C. Now, when the wind or current is against you, our capital R, our overall rate, is made up of little r minus C. Okay? And whereas little r is our rate or our effort in still air or water. And of course, C is the current or the wind. And also remember, for out and back problems, the distance out equals the distance back, or round trip. When we are traveling in opposite direction, we know that the distance of one train or person or car or bus or whatever, plus the distance of the second one, equals the total distance. And that opposite direction can be going away from each other, or they can be going towards each other. So remember that about opposite directions. You know, two things traveling towards each other are still going in opposite directions. Just like if they leave from the same location and travel due east and due west, that again is an opposite direction, where the distance of one plus the distance of the other equals the total distance. And in a catch-up problem, well, what do you know about distance when you catch up to somebody? The distance of one person will equal the distance of the second, because that means you've covered the same distance or equal distance. And the charts I use, rate times the amount of time equals our total distance. Now we may be rewriting some of this, but rate times time equals distance. We're going to multiply across, and we are probably going to add down, or we'll set one distance equal to another distance, or maybe even one time equal to another time. I think that's what we're going to see here in these next few problems. Okay? And again, we may have to rewrite time as a fraction, distance divided by rate. So, let's take a look at our first problem. A plane travels 100 miles against the wind. Okay? So we've got against the wind, and we're going to have with the wind. Okay? And we know when we're going against the wind is going to slow us down. That's going to be R minus C. And of course, with the wind will be R plus C. That'll make up our overall rate. So I'll just make a note of that on the side. So a plane travels 100 miles against the wind in the same time it takes to travel 120 miles with the wind. So it appears they're giving us our total distance here. Our total distance against the wind is 100 miles, and our total distance with the wind is 120. The wind speed is 20. Well, they're giving us C. Find the speed of the plane in still air. So they're asking us to find little r. We have C. So we have R minus 20 and R plus 20. And the times are the same. Now we might want to call these x, but we're not going to do that. It's going to be a little bit easier to do this with one variable. And let's take time and rewrite this as distance over rate. I have a distance, I have a rate. And the reason we're going to do this is because it takes the same time. Okay? These two times are the same, so we can set these times equal to each other. So, let's take a look at time. Time is distance over rate, isn't it? Okay? Rate times time equals distance. We divide both sides by r. We get time equals distance over rate. So, time is distance over rate. That would make our time 100 divided by r minus 20. And the time with the wind, 120 divided by r plus 20. And we know that these two times are the same. So 100 over r minus 20 will equal 100 over, will equal 120 over r plus 20. So one time is equal to the other time. And here we have a proportion. So we can simply multiply the means and extremes or cross multiply. So we get 100 times r plus 20 equals 120 times r minus 20. Now I'm going to do something. I am going to divide both sides by 100. We could divide by 120. We could distribute the 120 and the 100, but our number is going to be a little bit easier here. So if I divide by 100, I get r plus 20 equals, well, 120 over 100 is 12 over 10. That's 6 over 5 times r minus 20. Now, I can distribute the 6/5, but in order to get rid of the fraction, I'm just going to multiply every term by 5. So I multiply the r by 5. I get 5r plus 100 equals 6 times r minus 20. So simplifying, 5r plus 100 equals 6r minus 120. And I subtract 5r from both sides. I add 120 to both sides. And I get 220 equals r. And I think that might answer my question. I was charged with finding the speed of the plane in still air. Little r is the speed of the plane in still air. So r equals 220 miles per hour. That is our speed in still air. Let's move on to sample problem 2. A car travels 600 miles in the same time. So here we have it again, the same time that a motorcycle travels 450 miles. So we have a car and we have a cycle. And the car travels a distance of 600. The motorcycle travels a distance of 450. If the car's speed is 15 miles per hour more than the motorcycle's speed, so the car drives faster, that makes sense. And I don't know the motorcycle's speed, so I'll make that x, and the car's speed is x plus 15. And if they're traveling for the same amount of time, it would make sense that the one that covered more distance has got a faster speed, or the one that covers less distance has a slower speed. So our times are the same, so we're going to solve for time, and time is distance over rate. So we know that the time of the car will equal the time of the cycle. And time is distance over rate. So 600 divided by x plus 15 will equal 450 divided by x. So 600 the time of the car, or its distance divided by its rate, equals the time of the cycle, its distance divided by its rate. We cross multiply, we get 600x equals 450 times the quantity of x plus 15. So I've got this all set up for you. You can solve for x and answer the question. The answer is, or the question is to find the speed of the car and the speed of the motorcycle. So make sure you give me both rates in your answer when I see you in class.